my rectangles would start off going from this line to that curve, and then at some point they would start going from the two horizontal lines, but then at some point they would start going from that curve down to this horizontal line, and then at some point they would go from the function that's representing the top of this curve to the function that's representing the bottom of that curve. So at minimum, I would have 1, 2, 3, 4 different problems to do, and I would have to add them all up. Instead, I could just set up one problem, and all the horizontal rectangles can be represented by the one problem where the length of the rectangle is going from this x value to that x value. And the width of it is in the y direction. Alright, but since the width is in the y direction, I have to rewrite everything so that y is like my input variable. So that function over there, the g of y, is already written with y as the input variable, and the function over here is not. So before I get started, I need to take that function and rewrite it so that y would be the input variable. I need to find its inverse function. So I'm doing the college algebra topic right now of finding the inverse function. Alright, so to cancel e, you use natural log. So natural log of y is going to equal what was in the exponent of the e. And then I will subtract 5. And then I will multiply that by -2. And that gives me x all by itself. Technically, I should have absolute value signs here, but my y's are all positive, so I don't have to worry about that. Okay, so my rectangles are length times width. My length is given by the higher x value. The higher x values are given by the function g. G is further out down the positive x-axis than the first function. So x2, the higher x values, is given by the function g. -1 over 64, y minus 15